Hi, my name is John from Smile Dental Lab in San Jose, California, and I'm here to show you some of the successes that I've made in printing zirconia crowns and porcelain crowns, or porcelain slash with zirconia powder that I've been doing research for the past 2 years. Um, so I've been doing research for different types of resins, uh, starting with affordable ones, but some of them don't work because I don't think it's made for them. So I found these companies which made specific resins for certain materials or industrial and medical for printing, and then debinding means burning in slow process. Debinding means burning that resin so that the material left is the actual material itself. Okay, so now let me show you here what I mean. I've been printing, testing on my, this is the Form Labs Form 2. Um, I got it because I think that's one of the best vats that we can use for this, but I haven't actually converted it yet because it has a wiper. So every time before it cures the resin, the wiper would clean the surface, or would what you call this, uh, clear the surfaces. So anyway, this is the 3D printer that I used, which is the Elegoo DLP. Now, I chose Elegoo for the reason that instead of the other one, it was Anycubic, which I have here, Anycubic also. Uh, Anycubic, but I use it only for models. So, but the major one that I've been using is the DLP because the light source, I can't use LCD. I tried using LCD, but it doesn't work. It cannot print out properly. So here, as you can see, I've got uh, zirconia silicate powder, which is still zirconia. They use this for enamels or glazing powder, which is, still zirconia in different powder form. Um, so I've had my powder and resin mixture, um, and then so that's the zirconia. This one I mixed with Ceramco 3, which is a porcelain, but the Ceramco had a zirconia silicate, so because I made a wrong calculation, so I erased it, and because the resin that I was mixing wasn't a proper one, so it wasn't printing properly. So I corrected it. But this one that I used is a clear. It's a clear porcelain with zirconia silicate. So that's 70 and 30%. But when I was printing, this is the one that I printed. The 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 porcelain, and I have here also the Etria zirconia. So this is the stabilized zirconia, but the difference between the zirconia silicate and the Etria stabilized zirconia is the powder density, or the powder weight, is heavier. So I think it's better to mix the porcelain, or add the zirconia porcelain with about 10%. So but I over calculated and added 30%, which I'll change later. But right now I'm keeping this to print. I need at least 50 degrees Celsius. Right now it's 47. Actually, will go up to 50 because it's nighttime right now. It will go up to 50. When I do start print, it'll go up to 50. Anyway, um, this is the printout. The reason is I can't print lower than 50 because it doesn't come out properly. As you can see there, one actually one came off, but actually it's 100% perfect. It printed all perfectly, 100%. Just that the support that I did, well, it was like 99.9% perfect, but it's just that it's stuck in there because I didn't. Uh, well, sometimes it does that when it gets sticky. So if it's less, if the temperature goes down, it cools down. The powder goes down more, so it tends to stick. So that's why that one is left inside. So when I clean it up, I'll get the whole thing. So now I've done the printing successfully, which I've been trying to. Well, I started last year, so the whole year just to get this perfect. But before that, I was I was researching 2 years before that, or a year before that is the resins, the company that provides it. So I found companies. So uh, I got their resins, but tried to print on them unsuccessfully. So and then I found the right combination. Thank God found the right combination to print this properly. So now the next part will be debinding it and then and then cooking it, or we say firing it or sintering it. The sintering will be this one. So this one I printed the zirconia. It got dirty because I haven't cleaned it with the alcohol yet, so I still have to clean it up, soak it, clean it up with alcohol. So this is about 90% success, 95 I would say. Some of them got when I was cleaning it, some of them came off. This one, as you can see, half of it. Where can I show you? Yeah, there. So you can see half of it broke off. But actually, it printed some of it, and then this one came off from the actual support. So yeah, I have to. The only thing I need to adjust, it's actually printing the whole. As you can see here, it's all perfect. The only thing that I need to do is um, find. I think I need to also increase a little bit of the temperature because I printed this at 50 degrees. So I think the resin would need, because of the density of the powder is different from the porcelain. Porcelain is lighter. This is heavier, so I would need to increase the temperature at least about 2 degrees, and then I can have a better print out at least 100%. So right now it's 95%, which is still good because since I've been doing this since last year, early last year, and just 1 year later I was able to find the right combination of resin and then find the right settings. So this is the zirconia. So I did some debinding, sintering on it. The oven that I have, it only goes up to 1200 degrees Celsius. So when you debind it, it's all black. So that means it already burned out all the resin. and then on the sintering stage, it was actually like the ones you get from milling when it's in a green state, it's all white, like perfect white. That's how I get it. I cooked it for 4 hours, sintered it for 1200 degrees for 4 hours. It was actually really, really white, like paper white. And but when I pressed on it and crumbled it, it crumbled like a powder. So that means it needed more cooking time. But I think that's not just the reason. I think I need to have a higher temperature sinter. So 1200 is not going to do. It needs to be at least about 1500, I think, to properly cure it. Okay, so just to show you that I did print zirconia. All right, so now when I printed it, um, I did a microwave tests on it at 1200 watts of my microwave oven. Well, it's somebody threw away that microwave and I saw it. It was still working. It's just that the light was broken. So I fixed it, and well, I didn't fix the light, but I checked it, and the actual microwave works, and it has power in it. It's just that the bulb is broken. It doesn't mean anything, you know. So anyway, so I used it, and uh, I think I overcooked it because it's brown color. Look at that. It came out to brown. It's supposed to be either white or clear something because it's supposed to be clear, but the color is brown. So I think I overcooked it, and there's a crack on it. So I think not only did I overcook it, I cured it fast. So I was debinding it via microwave, and hey, success. It's hard. I mean, it's literally hard. I don't know how strong it is, but I'm not gonna check on it right now because I overcooked it. So it's not gonna be worth for me to check on how strong it is. Um, so I have to go back on the drawing board and see uh, the right uh, power level, because there's 1 to 10 power levels, so you got to choose which one from that. So to properly debind it, so I don't know if I'm gonna debind this first on my oven, my other porcelain oven. I have a regular pressable press oven that goes up to 1200 degrees. So I think I'm gonna do the debinding there first, and then transfer it on microwave and cook it on the microwave, because, or I don't know yet, but I'm gonna try do those tests first. It's gonna take time, but I really need a really strong, powerful microwave. So basically, I've already asked someone or paid somebody to. Uh, I need the control panel. I can build the the box itself for the microwave, and lock in where it's specific, because in microwaving this, you don't really need that turntable. You don't need that. You just need that space. So and then the wattage, the power, and that you need to really cook this, because the highest temperature that I checked with the 1200 watts uh, oven is that when you I bought this kiln on the internet on Amazon, those ones who fuse the glass together, they have this yeah, the microwave kiln that you can purchase. So I did that. I bought that, and check that it's about 1100 degrees. It can go up to 1100, 1000 to 1100 between that for that 1200 watts. I might be wrong because of the laser. I think the best one to scan the temperature is by putting in an actual sensor, ceramic sensor, inside it while it's heating up. So so the 1200 watts can go up to 1100, the heating temperature. But that's not only the good thing about it. Even though it only goes to 1100 watts, remember I said the temperature of my other pressable oven goes up to 1200 degrees Celsius. Yet, yeah, the only fault was this one was okay. I'll show you another. This one is zirconia. Okay, the first one that I showed you, the brown one, was porcelain. But anyway, so I really got that temperature for the right debinding and then the cooking, because it turned out really really white, the powder white. Okay, so I did a debinding on this, and there's cracks on this zirconia. There's crack over there, over here, over there. There's the crack on the side. It's like very very thin crack, and crack over here. Some cracks over there. Some cracks everywhere. Okay, but it's very thin. I'm sorry, I think my hand is shaking too much, or maybe oh, there you go. See those cracks? There are cracks there. There's a crack here. See on that line over there. So cracks on the surface. Yeah. So yeah. But the thing is, when you check this one, the color, I don't know if you can see proper color. It's brown over here. Not so much here, but brown over here. Not so much here. And the fault was I did this like this when I put it on my crucible. There was I have in the other room. It's a crucible tray with the glass beads. Okay, I put the glass beads in. You're supposed to put it like this. For me, stupidly, put it like this. So I did wrong, but that's fine, because hey, it's hard. When I press on it, it doesn't crumble. It's hard. So microwave, at that 1100 only. So the chemical composition reacts on it, because on heating only on that porcelain, my pressable porcelain oven, the 1200, even though it's all white, it's not enough. That heat is not enough. It's powder. When you press it, it just crumbles. But this one, I'm pressing hard on it. It's not. It's good. It's hard enough. Maybe my best guess about, well, difference also is freaking light. Normally, when you process this, when you cook this into the right temperature, the density becomes heavier and it becomes heavy. But this is freaking light. I mean, you can compare to other zirconias that are like this, molar. They're freaking heavy. This one is maybe about 1/3 of that weight. That's a big difference. About 1/3 of that weight from the ones that they mill. And the best thing about printing this is the undercuts. You can't mill the you can't do the undercuts while milling. This, so I overcooked it, and then plus debinding it. I read that I have to debind it slow. The good thing is power is 1 to 10, so that means I can go maybe to number two, power level number two. How many minutes? I don't know. I still have to do testings on it. So the one that's the main thing is, well, this one I used for used. So when I mix things, I don't use the new one and mix with the used one. So I separate it. And also number two is um, when after printing, after printing, you need to mix again. The reason is if you leave it there for after it's finished printing and you leave it there, you can't. You have to. Uh, I wish there was a machine that can mix it, but the problem is it has to have a constant temperature on that, like the one that Anycubic has. It has to be a little bit bigger, and the temperature has to be when it's passing through there, uh, because for the zirconia, I think I need to heat it up to with the resin that I'm mixing right now. Well, it's it's my research that I've done. So the real thing is the resin. That's the most important thing for binding this, because the ones they have is the resin that I have for other ones who can cure alumina or zirconia or other ones is it's not meant for the teeth. I tried it. It's not meant for it. So the ones I have is it's meant for this. So and one of those companies is resin is FDA approved already. So anyway, you don't really need the FDA because I'm burning all the resin, but the ones I have is already FDA. So anyway, uh, the FDA said, well, if you're burning it, because I called them up, if you're burning it all, which is yeah, of course, you have to burn it all, and then the product, which is also that's why I chose the zirconia silicate because it's FDA approved, and I have the proof, all of those for that material, because I was trying to choose between stabilized zirconia or U3 or the zirconia silicate. So I was researching, and the compositions are also, even though they're both zirconia, the silicate is far more lighter than the stabilized zirconia, than the U3 zirconia. U3 zirconia tends to be the density is it's too thick, and they're bigger. The from the size, molecule size, uh, they can have both the same strength, but the difference was the molecular size. The E3 zirconia, stabilized zirconia, is far more bigger than the zirconia silicate. That's the reason why. That's the reason why the the weight. Okay, um, so I need something higher. So I'm gonna build my own microwave oven. So right now, even though this is being cured by the microwave, it's not strong enough, and I have to cure every single time because the maximum, the 10, would only run for 30 minutes, and I've run this a couple of times continuously, according to my calculation. Although I overburned it, so now I can go back and see what proper length, but it's not going to be 6 hours basically from start to finish. When on my pressable oven, the whole thing will take about, what's that, 10 hours to 12 just to process the zirconia. That's a long time. When I was doing it on microwave, the most I got was about 2 hours. So 2.5, I think. About, yeah, more or less within 2 to 2.5 hours. But then I have to recalculate everything and then check every the debinding. I have to check that first. Check the color, check how it looks before finishing, because the kiln that I use, it has this graphene around it, which is the black thing. So then it heats up. That one really glows. So even though my microwave or the junk microwave that was thrown out doesn't have a light, once you turn it on, you can see that thing glow, literally glow. Okay, so and when you're curing, or when I'm cooking that here, because there's two types of crucible, one that's covered and one that has open. So note, the open one needs to be used, because when you burn that acrylic, that's kind of like a gas thing, which is chemicals, which is no good. It needs to be vented out. So that's why I have a fan that sucks out up. So that needs to be sucked out. So I attached something there to suck out all that fume. And then not only did it cure it nicely, but the heat also, so there's two reactions: the microwave, the wave that's creating there, and the heat that's building inside. I guess that's the one that cured it, only at 1100 degrees. Surprisingly, well, 1000 to 1100 Celsius. Not exact, as I've said. I have that jet sensor, which is, I'm censoring outside. So inside, you need to actually, which I can't. So much money. So anyway, I have a video that I showed how to do this, because this one, see, it's connected to this temperature controller. So I had a plug in there, as you can see in the back side. So I connected it to here, made its own portal, or own power to connect. So I drilled a hole on this one. What is this? Anyway, so just to connect this power, which is a 24 volts, because this one has I put this what you call this, made in China, film heater plates. See, it has an adhesive at the back, so it's cheap. So it doesn't last long because the temperature tends to be high. So when it gets bad, it goes black until later on it doesn't heat well. So I've used it for quite a while already. So I know I would need to change this one. So that's all I need to. That's what I did. Here, as you can see here, I have one here. It's a sample. So where did I put the other tray? So yeah. So this one, again, on my other video. What was that? Okay, let me show you how to do that. Where did I put? Okay. I took it off, but I forgot where I put it. See, I have the other cover, but I don't know where I put it. found it. Okay, I found it. So basically, I made a mark on it. See, there's a mark there. The reason is I have to drill inside the hole. As you can see, I don't know if I can see. Where is that? Oh, yeah, here. Um, if you can see, there's a mark also inside. See there? There's a mark because when this is inside, see, it sits on a certain level. So I have to drill without touching this. So this won't be touched. So it has to be drilled under there. Where I also have to grind this surface here before the ones connecting to this screw, but not the screw. So you have to be before that. So the reason is I grind here is so that where did I put? So that I can connect this. I can connect this to here, and then because it has adhesive, so I can press on it here, so it hits up this surface. I don't. Some other videos they have it outside here, but the problem is the heat generates a lot of heat out here and not in here. So the rest, remember, the resin is inside, not outside. So um, that's why what I did with this one is this one once I cut off, because it has to be it has to go underneath that level. It doesn't touch this one. So when you put it, it doesn't touch it. So anyway, I can add, so this I adhesive on this side, which is the inner part. So this one heats up a lot more. So that means the resin will heat up. And then the good thing apart about it is because it's, so when you heat it up, it's okay, yeah, heat it up because it's on the inside, and then it's close to this. So this build plate, this plate itself heats up too quickly, although it's not touching all the way. Uh, uh, that part that this one is touching heats up the whole PFA, this plastic, which can it says it can go up to 100 degrees Celsius. So it can take up to 100 degrees Celsius. So that's half. So that is fine. So it heats up and really heats up the resin. Okay, the resin itself. Okay, not the one that you have the blower heater. The blower heater doesn't heat up the resin. It only heats up the surface. You need to heat up the actual resin. So I did that before. The one outside, it doesn't work. So when I would hold this one, I have to put something here or wear something gloves, that because it was too hot. It wasn't hot in here. It was hot more outside. So that was useless. So yeah. So now I know that I needed. So that's why I got this. Well, it's a little bit short. I should have bought ones that are longer, about 150 millimeters. Should have bought 150 because once you cut through here to insert this, make sure that when you cut it, it's more than, what is this? This is about 10 millimeters. So when you cut it, you cut about 11 millimeters or 12, which is better. And then once you've cut that, you insert this, but then you insert it this way because you need to press so that it'll stick on this and then stick on this surface, the one inside. Okay, not the one outside, the one inside. So that means this one will heat up. The surface here will heat up. So I have only 4 left, which is good for, but I know I should have gotten 150 millimeters, which will cover more surface and heat up more. I think it will last. It will last more because this surface heats up a lot for a small area. This is only 100. So, uh, but I'll still use it because I don't want to waste it. I think I can put it on this side. Yeah, put it on this side so I can have more room. But I'm only doing a 24 volts for this 24 volts. So basically, when you have this, the two, because this is 12 volts, so you get this at 12 volts. So 12, and then you connect one part together, one part, this one together, you connect them together, and then one will be positive, one will be negative. Okay, that's how you connect it, and it becomes 24 volts. But remember to buy this at 12 volts only, and then you get this controller, temperature controller for 24 volts. So there's also 12 volts, but you don't want the 12 volts. You want to do the 24 volts. Because later on when you do the connection, the wiring, you will only have to do 4 pins. See, it's only 4 pins. So because 12 volts, then you'll have to do 6 pins, and that's more of a hassle to do. So you want to, yeah. So that's it. So successfully, I've done the porcelain and the zirconia printing. Now my next project will be chrome cobalt powder. So yeah, I put what is this? 80%. What do you mean? 140 grams or 80% powder. Okay, the between the liquid and the powder is only, yeah, chrome cobalt. So I have here the mixture of the powder with just iron. Oh shucks, I knew I forgot something. I forgot to put carbon, which is about 1%. Yeah, you need to put a carbon in it, at least 1%. On my research, that's how you do because when it's I will do the heat treating it, not using argon. Okay, I'm gonna use a microwave. So, but I need at least 1% of carbon. On all of those, there's always a 1% carbon for oxidation, I think. Part of it's for the oxidation. But because I'm microwaving it, not heating it like regular heat treatment, this is a microwave treatment, so there's a difference. In a heat treatment, you need at least 0.5 of pressure of argon, but I'm not going to do that. I'm going to do microwave, so you don't need it. So this is the next project, and hopefully, shoot, this is also heavy. I can see from here, the resin, the powder. Okay, the resin here, there's a resin, if you can see it. Well, it's here, the separates itself. So in this one, I put this in I have this wax wax bath to not melt, but to make the wax soft. So I use that as my heating. You heat this up first, and then I put it on my well, actually I bought online this it has its own heater mixer. So basically you put this in there and then it mixes, and at the same time you can press how hot you want it. but it doesn't get hot to what I want. So before I put it in there, I put this first on my heating bath, about 60 Celsius, because I don't know what temperature I need to print this. So that's also another research. uh, 60, and then after that I put it on the mixer, which mixes, but I still shake it first just to add more to that, and then I mix it for about an hour. It goes to that mixer with the temperature heater, and then after that then I put it in here, and then with the temperature, uh, but I don't have the oh yeah, I'm building this for, so that's why this one I'm making it for this, because I haven't prepared it yet. Although I already punched something there so that I can drill a hole on it. So this will be for my other project, not that one that I need. But I bought a new what you call this, a new build plate, because I don't want to. I want to use each one at their own. I don't want to keep changing, mixing, cleaning. That's more of a hassle. So this one, because it's all dried up, a little bit dried up, I just need to get my spatula and drop it in there and not clean most of it. Only this, I put the alcohol on the tissue. When I take this off, I just clean that up with the tissue. I don't spray it on here because there's still some powder left in there. So when it heats up, I think it goes down. So it melts in there. So, not waste. But I still, this one's, that's dried up already. Those one I use the spatula to take it off and then put it in there. And then put it back on my other uh, another cartridge like this that has well, I still have to make one for used porcelain. I have to make one because I just bought some, so I'm waiting for it to arrive. And then yeah, that's the one I use for used. And then you know the new ones I don't touch. I only just refill it. That's all I do. So you don't want to waste so much mixture. So anyway, that's it. So next time when I successfully print for that chrome cobalt, then next will be titanium. You know, that means implant parts. You can 3D print precisely, so it will be accessible to everybody. Because here I'm only using Elegoo, okay, DLP. The reason why I used Elegoo, not Anycubic, is because Elegoo had this aluminum vat. Okay, the Anycubic has the plastic, and I did that on the plastic. I actually put that temperature, uh, this heating pads, and then the plastic distorted. Yeah. So I don't know if I can use it, but I can show you here. And show it. Does it show it there? See those white ones? These are bumps actually already here, so they're distorted inside. I don't know. I don't know if I can still use this. Um, we'll see. I'll check if I can still use it, but I know I can't heat it up anymore because the more I heat it up, it's going to distort. This was just one heating up to 45 degrees Celsius, and sheesh, it already at 45 it already distorted. So if I go 50, oh, it's going to distort more. So yeah, that's the difference between Anycubic and Elegoo. So that's why I chose Elegoo. Uh, that means the quality is good. Plus, they have that filter, built-in filter, which is very helpful for the smell. Because the resin I got has a smell, not too strong of a smell, but still smell like not the first versions when resin like those 3D Anycubic 3D resins. These are really smelly. Okay, uh, this smells, but not as strong as those specialty products. But still smells. It's still a strong resin smell. Uh, okay, and yeah. So I can't tell all of those secrets on what type of resin, but it took me a year to do my research and a lot of spending to buy different types of resins, and I had to throw some of them. No, I don't think I threw. Yeah, some of them I'm not using because I really can't use them. So spending money on those that you can't use is it's a waste. So hopefully in future this research of mine gives back something in return. All right, thank you very much for listening. So I will keep you updated when there's something to update. So yeah, time to do my research now. Thank you. Bye.